Hello and welcome to Sciencera. In this video, we will be looking at discrete probability distribution, which is chapter number 5 of business statistics. So, the objectives for today's video is you should be able to recognize and define a discrete probability distribution, construct a probability distribution for a discrete random variable, understand the concept of Bernoulli process and its application, consecutive trials as associated with binomial distribution. You should be able to differentiate between the binomial and Poisson distribution. Determine the probability that a binomial variable will assume a given value and a Poisson variable a value within a given range. So let's look at the random variable first. A random variable is a variable that can take on different values. It can either be discrete or continuous. If a random variable is discrete, it can assume only a countable number of possible values. If it is continuous, there will be uncountable number of possible values. It can take on any value in one or more intervals of values. Next is probability function. What do you think is a probability function? A function of a discrete random variable that gives the probability that outcome associated with the variable with that variable will occur. The two key properties of probability function are that probability should be less than 0 and greater than 1. Less than 1, sorry. For any x value, it should be between 0 and 1. The probability function. If probability is equal to 1, that is the sum of probabilities of all possible outcomes x for a random variable x equals 1. Collectively exhaustive event. These are the events in which all possible outcomes are included. Probability distribution for a discrete variable. A probability distribution for a discrete variable is mutually exclusive list of all the possible numerical outcomes along with the probability of occurrence of each outcome. So here's a graphical representation of a probability distribution of number of interruptions per day. For 0 interruption, probability is 0.35. Remember, probability is always between 0 and 1. It is not less than 0 and it is not greater than 1. Next is expected values of the discrete variable. This is the formula we use to calculate the expected values of discrete variable. For any exam or assignment, you should be able to write this on your own and you should learn these, right? So, in this formula, xi is the ith outcome of discrete random variable x, and pxi, this one here, is the probability of occurrence of the ith outcome of x. So let's look at the example, you'll understand better. Expected value of the discrete variable. It also means calculating the mean. Mean is your expected value. To calculate the expected value, you multiply each possible outcomes, which is xi, by its corresponding probability, which is a probability where x is equal to xi, and the sum, and then sum these products. So here we have the same chart we saw before for the interruption per day and the probability. So how do you calculate the expected value? You times interruption per day with the probability of each interruptions and then you add them all. So you will get 1.40. This is the mean value or the expected value of the discrete variable. Next is variance and standard deviation of the discrete value. For variance, you use this formula, where xi is the ith value of the discrete variable, x and the probability p is the probability of occurrence of ith value of x. Standard deviation is the square root of variance. So let's look at how. So in the last slide, we calculated the expected value, which is 1.40, and then now they're asking you to calculate the variance and standard deviation of the given data. So in order to compute the variance of a probability distribution, what you need to do is multiply each possible squared difference by its corresponding probability and then summing the resulting product. So what you have to do is you have to square the difference, right, with the probability. So it's 0 minus 1.4 square, and then you multiply that difference by the given probability. For the first instance, it is 0.35. So a possible squared difference times it by the probability. So for interruptions per day, when we have one interruption per day, what you're going to do is 1 minus expected value. You'll get the answer, and then whatever answer you get, you can square it and then times that answer by the given corresponding probability, which is 0.2. Once you're done calculating all these, you need to add them to get the variance, and then find the square root of the given calculated variance to find the standard deviation. Next is the binomial distribution. So now here we have binomial distribution. Binomial distribution describes the probability distribution resulting from the outcome of binomial experiment. Binomial experiments usually involve several repetition of the basic experiments. Binomial probability distribution gives us the probability that a success will occur x times in a trial. So x can be 0, 1, 2 till the nth value. So here binomial distribution can be a fixed number of observation n, right? For example, 15 tosses of a coin, 10 light bulbs taken from a warehouse. So it's a fixed number of observations. 15. So 15 in the case of coin is the fixed observation, right? And 10 in case of light bulb is the fixed number of observation. Second point is each observation is categorized as to whether the event of interest occur. So, for example, head or tail in each case of a toss of a coin. Defective or not defective light bulb in the case of light bulb taken from a warehouse. Since these two categories are mutually exclusive and collectively exhaustive, when the probability of the event of interest is represented as pi, then the probability of the event of interest not occurring is 1 minus pi. Constant probability for the event of interest occurring for each observation is pi. So for example, probability of getting tail is same each time we toss the coin. So this is the pi value. If we have to find event that is event of interest which is not occurring, so we will say 1 minus pi. Observations are independent in the binomial distribution. Outcomes of one observation will not affect other outcomes. Binomial distribution counting technique. So suppose the event of interest is obtaining head on the toss of a fair coin. You are to toss the coin 3 times. In how many ways you can get 2 heads? So possible ways will be head, head, tail, head, tail, head, tail, head, head, right? So these are the 3 possible ways of getting 2 heads. This situation is simple. We need to be able to count the number of ways for more complicated situations. So let's see. In order to apply counting technique, here you can see this formula, or it is called the rule of combination. So in this case, n is the number of observation, x is equal to the number of events of interest in the sample. So this will give you number of combinations of x event of interest out of the n observations, right? N here is called n fractional. By definition, 0 explanation mark is equal to 1. So here I have an example of rule of combination. So let's look at this example. How many possible 3 scoop combination could you create at an ice cream parlor if you have 31 flavors to select from? So total choice is n equals 31, right? We have 31 flavors we can select from, and we have x 3 scoop, so combination is 3. What you're going to do is n is equal to 31, x is equal to 3, so you will say 31 over 3 times 31 minus 3, which will give you the 4495 combinations. Next is characteristics of binomial distribution. The experiment must consist of an n-identical trial. Each trial has one of the 2 possible mutually exclusive outcomes. It can be success or failure. Probability pi that the trial will result in a success remains the same from trial to trial. The trials are independent of one another. The outcome of a trial does not affect the outcome of any other trial. The probability distribution of the number of successes x of random variable x in n trial of a binomial experiment is this. So we will add in the rule of combination this, which represents the probability of exactly x events of interest from an observation in a particular sequence. So in this case, n is equal to number of trials or sample size, pi is equal to probability of success on each trial, x is equal to number of events of interest in the sample. So here you can see the binomial distribution formula. Px in this case is equal to the probability of x events of interest in n trials, with the probability of an event of interest being pi for each trial, right? So as I said before, x is equal to number of events of interest in a sample, which can be any number integer. N is equal to the sample size. Sample size is observation or number of trials. Pi is equal to the probability of an event of interest. Next I have an example of binomial probability. So what is this probability of one success in 5 observation if the probability of an event of interest is 0.1? So first you need to write what is the value of x, right? We have to find one possible success, a probability of one success. So x will be 1. How many observations we have? We have 5 observations. So n equals to 5, and then pi is 0.1. Right. So you will use the binomial probability formula. You will add all the values as given, and then you calculate the probability of one success in 5 observation, right? So Here you can see 1 minus pi. This is the probability of not having an event of interest in the formula. Binomial distribution and shape. The shape of binomial distribution depends on the value of pi and n. So pi we have is the probability of an event of interest and n is the number of observation. So here n equals 5 and pi equals 0.1. And in the second case n equals 5 and pi equals 0.5. Whenever pi is equal to 0.5, the binomial distribution is symmetrical, regardless of how large or small the value of n. When pi is not equal to 0.5, the distribution is skewed. The closer the pi is to 0.5 and the larger the number of observations n, the less skewed the distribution is. So in the first case pi is 0.1. So the graph is binomial distribution shape is rightly skewed, right? When pi is equal to 0.5, this is symmetrical. Binomial distribution characteristics. Mean, it is equal to the same size multiplied by the probability of an event of interest. Standard deviation we will square root the variance to calculate standard deviation. In this case, n times pi, 1 minus pi. N is the sample size, pi is probability of event of interest for any trial, and then 1 minus pi is probability of no event of interest for any trial. So, in order to calculate mean, you need to time sample size by the probability of event of interest for any trial. To calculate the standard deviation, you need to take the square root times the sample size by probability of event of interest and then times that with the probability of no event of interest for any trial. Okay, here's an example of what we saw before, right? You have given graph, you have given the value of n and pi. To calculate mean, you have to times n by pi, right? So 5 times 0.1 will give you 0.5. And then for the standard deviation, square root of variance. To calculate variance, you have to times n times pi over 1 minus pi. 1 minus pi is the probability of not having an event of interest, and pi is the probability of event of interest, whereas n is the number of observation. So 5 times 0.1 times 1 minus 0.1. So it will give you the standard deviation for the square root of the answer will give you the standard deviation for graph 1, and we'll do the same for the graph 2. Next we have the Poisson distribution. The Poisson distribution is a discrete distribution for an event for which the probability of occurrence over the given span of time, space or distance is extremely small. An area of opportunity is a continuous unit or interval of time, volume, or such area in which more than one occurrence of an event can occur. For example, number of scratches in a car paint, number of mosquitoes bite on a person, and number of computer crashes in a day. Next, how do you apply the Poisson distribution? When can you apply it? You wish to count the number of times an event occurs in a given area of opportunity. So you will apply the Poisson distribution. The probability that an event occurs in one area of opportunity is same as all the area of opportunity. Next is the number of events that occur in one area of opportunity is independent of the number of events that occur in the other areas of opportunity. The probability that two or more events occur in an area of opportunity approaches zero as the area of opportunity becomes smaller. The average number of events per unit is called lambda. Here I have a formula of Poisson distribution. So, in this formula, the x is 0, 1, 2, 3, any number. Lambda is mean number of occurrence in the interval. And this E here is the Euler's constant, which is always 2.71828. X is the number of events, right? So next, we'll look at the example of Poisson. A bank receives an average 6 bad checks per day. The probability that it will receive exactly 4 bad checks on a given day is what? So, in order to calculate the probability of a bad check on a given day, which should be exactly 4, we have to use the Poisson distribution formula. So we know that lambda is 6, that average bad check is 6. Lambda is the expected number of events per unit, which is given 6. And probability of x equals 4 will be what? So we know the lambda is 6 times over 4. Point E is the Euler's constant over the number of events, which is 4. So you will calculate this value and you will get 0.1339. So the answer will be 4. Thank you so much. This will be all for discrete probability distributions. If you need the notes for this chapter, you can go on the Facebook page, like my page please, and don't forget to subscribe. Thank you.